The moon illusion is how the moon can appear to be vastly different sizes in the sky. Like it can appear to be 50% larger in diameter or 125% larger in area when it's closer to the horizon than when it's directly overhead, but it's actually the same size. It's one of the oldest known psychological phenomena, having been written about as far back as ancient Egypt and China. You can tell that the moon doesn't actually change size over the course of a night by sticking your finger out arm's length in front of you. The moon takes up about half a degree in angular size. Your pinky finger is just about the right size to eclipse a full moon, whether it's near the horizon or up surrounded by void and stars. You can also compare its actual size in photographs, or a surveying tool called a theodolite to measure its angular size. Also, weirdly, you can make the moon illusion disappear by bending over and looking at the moon between your legs. In reality, the eccentricity of the moon's orbit around the Earth means that it actually can vary in apparent size depending on how close it is. Full moon at apogee, when it's furthest away, can appear 12% smaller in diameter or 30% smaller in area than at perigee when it's closest away. It's a bit hard to see at this scale, but the moon is about a light second away from the Earth. Here at apogee, it's about 252,000 miles away from us, but at perigee, it's about 225,000 miles away from us, or a 12% difference. The actually larger looking moon at perigee is called a supermoon, and here it is compared to a standard regular old average sized moon. And here's a NASA image comparing it to a micromoon. Even so, that actual change in apparent size is insignificant compared to its illusory change in size. Also, it takes about 2 weeks for the moon to go from perigee to apogee, and you can see the apparent change in size of the moon due to the moon illusion over the course of a night. One explanation for the illusion is that it's an effect of relative size, like this here Ebbinghaus illusion. Both central circles are the same size, but the one surrounded by smaller circles looks bigger. Kinda like, but less like the spaghetti. The thought is that when the moon is surrounded by more empty space, it looks smaller. Another hypothesis for it is that it's an effect of how we perceive relative distances. Like in this picture, the moon looks like it's just behind the trees on this little precipice here. When Luna is high in the sky, the clouds in the foreground are closer to the observer and look bigger, so the moon looks smaller in comparison. It's like this Ponzo illusion of forced perspective where it looks like the yellow line closer to you on the railroad tracks is littler than the line further down the track. And of course they're the same size. Really though, there are like 10 different unique explanations for why it happens with different degrees of merit. I think like so many things, it's probably not boiled downable to just one single thing, so no single explanation will suffice. Because there's a big old mix of things going on in our weird little noggins.